Okay, so we are given a parallelogram. Let's draw the diagram. So suppose it is P, Q, R, S. Now they have said that X lies on side QR such that QX is equal to 4XR. So it will be something like this. This will be point X and the ratio is 4:1. And Y lies on RS such that RY is equal to 4RS. So this will be point Y and the ratio is 4:1 like this. Now let's join PR and XY, and they have said that the intersection of these two lines is Z. Now we have to prove that PZ upon PR is equal to 21 upon 25. So let's assume coordinates of R. Say that R is situated at the origin. So the position vector of Q will be Q bar and position vector of S, point S, will be S bar. So by parallelogram law, the position vector of point P is Q bar plus S bar. Now to find out the position vector of point X, let us apply section formula. So it is 4 into 0 and Q into 1 upon 4 plus 1. So that is just Q upon 4 plus 1 is 5. Okay. So doing the same thing for point Y, it will be 4 into S plus 1 into 0 upon 4 plus 1, so 5. So that is 4S upon 5. Alright, so we have the position vectors of all the points now except Z, and that's what we have to find out. Now let's assume that Z is dividing PR in the ratio lambda is to 1 and Z is dividing XY in the ratio mu is to 1. So again, using section formula, we can find out the coordinates of Z in two different ways, using the ratio mu is to 1 and another time using the ratio lambda is to 1. So let's do it. So the coordinates, the position vector of Z is equivalent to, firstly let's do for P and R. So it will be using section formula, the position vector of P into 1, so that's Q plus S, and then lambda into 0, so that's 0 upon lambda plus 1. Now let's do for mu is to 1, that is line XY, so that is mu into X. This is equal to X is Q upon 5 plus 1 into Y. So we know that Y is 4S upon 5 and the whole thing is divided by mu plus 1. Okay. So now we can obviously see that Q and S are non-collinear. So we have to equate the coefficients of Q and S in this case. So equating the coefficients of Q, we have 1 upon lambda plus 1 is equal to mu upon 5 mu plus 1, and the second equation equating S will become 1 upon lambda plus 1 is equal to 4 upon 5 mu plus 1. Okay. So now we have two equations and two variables. We can find out the value. First, let us divide both of these equations. So lambda plus 1 will get cancelled and 5 mu plus 1 will also get cancelled. So we are getting 1 is equal to mu by 4. So mu is equal to 4. Now substituting mu is equal to 4 in any one of these equations. Let's do it in first one. Let's take reciprocal. So lambda plus 1 is equal to 5 mu plus 1 is 5 upon 4. So that is 25 upon 4. 25 upon 4. And that is mu plus 1. So that is lambda plus 1, sorry. So mu plus 1 will be 25 upon 4 minus 1. So 25 minus 4, that is 21 upon 4. Okay. And we have to prove that Pz upon Pr. So Pz upon Pr. Pz is lambda and Pr is the total length. So that is lambda plus 1. So we have to prove that Pz upon Pr is 21 upon 25. So here we have the value of lambda plus 1 and here we have the value of lambda. So we just have to take the ratio of that. So lambda is 21 upon 4 upon 25 upon 4. 4 will get cancelled and we are left with 21 upon 25. So our answer is complete.